In this video, we're going to be working on solving multi-step inequalities. Now, before we get into inequalities and reviewing all of the symbols, let's start with the word problem. Now, this word problem is a different take on the one that we looked at in the solving literal equations video. So if you want to go take a look at that, that's a different take on this. But here's the problem. You plan to order white carnations for your sweetheart. The flower shop charges $2 per white carnation and a $5 handling fee. You want your total bill to come out to at most $20. Write an equation to represent the situation. Okay, so let's kind of think about what's going on here in this particular problem. So what's the unknown in this problem? Well, the unknown that we have, let's get my pen showing up. Okay. So the unknown that we have here from looking at this problem is the number of white carnations. That's the thing we don't know. So we're going to define that as our variable, because that's what we need to figure out eventually is how many flowers can we buy. So there's our variable. So let's kind of describe what's going on. So I've got $2 for white carnation and a $5 handling fee. Now, typically handling fees, those don't change. They just tack on $5 to whatever they're charging. So if I were to write this as an equation, I would do 2x, because I have 2 per carnation, so 2 times my carnations, so that's x, plus my handling fee, and we want it to be $20. Now, I didn't put an equal sign here because this problem is actually not an example of an equation. So we actually can't do an equation here. Unfortunately, that's not going to work because we have this little phrase here that says at most. When we see phrases like at most or at least, what that does is it tells me that there's more than one possible answer. For example, I could just buy one carnation, have a total of $7 and be good. That's at most $20. So we have to look at multiple cases. And so when we're looking at multiple cases, that implies an inequality. So this phrase tells me I want to use an inequality. And the inequality I want to use is I want 20 to be the biggest number I have. So I want my charged amount, 2x plus 5, to be, this is called less than or equal to 20. So that phrase at most gives me the clue that, hey, this is an inequality. I have to look at more than one possible case. Now, before I get into how to solve this, let's review what the different inequality symbols are. So there are 4 inequality symbols that we're going to look at. So this first one here is called the less than sign. The way I like to remember it is if you hold up your left hand, it looks like the little line between your pointer finger and your thumb. So that's the less than sign. So think left hand less. The next one is called greater than. So we've got the mouth opening to the left. That is called greater than. Now these two are very similar. You see we have that bar underneath that is called less than or equal to. When I'm using a less than or equal to, we would say something, for example, we could say 2 is less than or equal to 2. Just as an example, now we know that 2 is not less than 2. That is not a true statement. That is sounds weird. We can't say a number smaller than itself. But they are equal to each other. When we have the equal to, that includes the number itself. And then we have greater than or equal to. So we have strictly less than, greater than. Then the equal to means that the number itself counts as part of the solution. So let's look at how we solve these. So I have an example here. And when we look to solve this, it looks very similar to an equation. If I were to replace my less than sign here with an equals, we know exactly what to do. And conveniently, to solve an inequality, we follow the exact same steps. So this is the same steps for solving an equation. We're still going to do the same thing. There's one little caveat, and we'll get to that in a little bit, but we're still going to follow the distributive property, clear fractions, combine like terms on the same side, move all variable terms, undo addition, subtraction, undo multiplication and division. So the steps for solving inequality are the exact same except for one little caveat, and we'll get to that right now. Well, actually, we'll get that in a second. So let's solve this problem. So I'm still going to draw my brick wall. I'm going to draw this to keep myself organized. And I'm going to start with distributing. So I see these giant parentheses, so I'm going to multiply. So I have 3x plus 6 is less than 7. Next, I need to undo this plus 6. I'm going to subtract 6 from both sides. So that cancels. So I have 3x is less than 1. And then I'm going to divide by 3. So I get x is less than 1/3. Now, besides solving these, we also want to be able to graph these, because if I'm looking at this answer, this implies more than one solution. This has more than one answer. Inequalities have an infinite number of solutions. There's more than one. So when I'm looking at this, I want to be able to graph this. Now, if you want to review graphing, there's a video posted that you can review graphing. I'm just going to do a quick little drawing here. So I've got my 0, I've got 1/3, I've got 2/3. Let's change colors here. So in this case, 1/3 is not a solution. Since I don't have an equal to, I'm going to put an open circle on the 1/3. Now, since x is smaller, all of my numbers are smaller than 1/3, all of them that are my solutions. So what I'm going to do is I'm going to draw an arrow to the left, showing any number smaller than 1/3 will work in this original inequality. So I could plug in 0 and this would work. I could plug in -100 and that would work. So any number smaller than 1/3 is an answer. And this arrow keeps going forever because there's an infinite number of possibilities. The solving is very similar. It is the same process as when we solve equations. However, like I mentioned a little bit ago, there's one issue, and I'm going to show you the one issue and we'll talk about why. So here's a big reminder. So we solve an inequality just like an equation, except when we divide by negative. So when we divide by a negative number, you have to flip the inequality. You have to flip the inequality sign. So if it was a greater than, it needs to flip to be a less than. And let me show you why. So let's say, for example, I have 4 is less than 5. Okay, so real straightforward. So I'm going to have 4 is less than 5. And this should also say multiply when we divide or multiply by negative. So let's say I multiply everything here by -1. So I would have -4 and -5. Now, if we think about this too much, can I say that -4 is less than -5? No, that's not how that works. When we're dealing with negatives, the signs are flipped. So -4 is actually bigger than -5. So that's why that works, is because the negatives, they're flip-flopped. The -4 is bigger than -5. And then we roll from there. So let's do one example where we have to flip the sign. So here I've got -5 is less than -m plus 10. So let's start by moving this 10. So I'm going to subtract 10 from both sides, minus 10. So I have -15, that cancels, is less than -m. You could be thinking, well, what do I do with this negative? Well, it's a -1. So since this is times -1, we're going to divide both sides by -1. So I get 15m. Now, since I divided by a negative here, see, I divided by -1, we are going to flip this inequality to be a greater than. So what that tells me is that all of my solutions are smaller, since the arrow's pointing there, is smaller than 15. So I could write it this way, or I could write it as m is less than 15. Whichever one makes sense to you is fine, so long as the arrow is still pointing at the same thing. Then when I go to graph it, I want to show all the possible solutions, because remember, there's an infinite number of possibilities here. 15, 16. So at 15, it is not a solution because there's no equal to, so I put my open. And then I want to go to the left because I'm showing all of my numbers smaller than 15 are solutions. So that's it. That's how you solve inequalities. You follow all the normal steps, except when you multiply or divide by a negative, you have to flip the sign.